signs of a physical Earth curve edge, formerly known as the geometric horizon?
Not since 2019.
Yeah, geometric horizons are very 2019, aren't they? And 2018 and 2017. Any signs of any Earth curvature?
From Lake Mojave.
I reckon those two should be amalgamated, chocolate. In light of what you've been saying this a few times, and I had cottoned on to exactly what you were saying, but you put it in a really concise way on Ballbusters. Do you know what I'm talking about?
Yeah, how the geometric horizon used to be called the curve, and how it's not called that anymore. And there's now the absolute certainty that we've never seen the geometric horizon, aka the curve. But yeah, I would feel like both questions are kind of the same, but
they seemed kind of the same up until this point. But by the same token, the distinction is maybe how they've got away with it. Us realizing and discussing this verbally now is kind of an appreciation of that. There was a distinction being made between a physical demarcation point marked with an X in the model and what they actually discuss, which was how much is blocked of the target. That's what's being discussed when you talk about the calculator, right? The hidden value. So it's not really the prevailing part of the mathematics that you're being taken to. And what you're describing is things going over Earth curvature. But in reality, as you highlighted on Ballbusters and just a moment ago, that's Earth curve. What was formerly called Earth curve is the geometric horizon when you're quantifying it mathematically. The geometry giving you the physical geometric Earth curve edge, otherwise known as their heliocentric geometric horizon. Earth curve.
Yeah, I agree. And if that's the case, then the answer to the first question would kind of be then yes, because there is sign of that in the model, right?
Yeah.
It's just that when we apply that to reality, all of a sudden, no. So I guess you could say it like that. If you ask the first question, is there any sign of the physical Earth curve edge in the model? Yeah, sure. There's supposed to be one, right?
That's the
But
answer to the
now
second
when we
question.
get to questions, sorry, go ahead.
I was just going to say that's the answer to the second question. So the answer to the second question, any signs of Earth curve? Well, yeah. The Earth curve's in the Earth curve model.
Yeah. I know what you mean.
Well, when you take Neil deGrasse Tyson saying that stuff is flat, and he takes his hand and makes a flat sign out of it, and he's saying how high you have to get to see the curve, chocolate, according to Neil deGrasse Tyson?
Well, he did establish how high you have to go to see it. He says how high you are that you can't see it from.
Okay,
So
what was
you
that high?
can't see it from 128,000 feet.
Okay, so my point is, if you can't see it from 128,000 feet, how in the world is it supposed to be 1.22 miles in front of you at 1 foot observer height?
Aha.
Well, the answer to that
There goes the trick.
The answer to that is to work your way back in terms of what you're doing when you use the maths. First step, take geometric consideration when looking at a non-physical, non-geometric location called the horizon. From there, you can reify that non-physical, constantly moving position called the horizon into a physical geometric Earth curve edge obstruction when you look at things beyond the horizon. Now, when I say with an elongated tone beyond, it's because what you're seeing is something that has an angular size greater than the diffraction limit at that point, or atmospheric conditions that would bring that horizon closer, causing the same effect or entire obstruction in the case of things like fog. My point being that the geometric consideration is the first thing that you will do. Reify something into a physical position. Later once you've gone through all of that process, deny entirely that the horizon marked with an X and labelled horizon in the geometric model is anything we would ever see in reality, as some sort of excuse upon reifying that physical geometric edge marked with an X and labelled horizon in their model into the horizon we actually see.
Well, my point, maybe I didn't say it right, is Neil deGrasse Tyson is agreeing with us that the radius of the Earth cannot be 3,959 miles.
Well, his statement's false based on their geometry. No, Mr. Tyson, according to your own rhetoric, we can measure Earth curve from the ground. So him saying that we can't see Earth curve from 120,000 feet when pointing out Felix Baumgartner's jump with fisheye lenses, again, our argument used as some sort of defence by Neil deGrasse Tyson, but also making both parties, Flat Earth and Globe Earth, reify the horizon into an edge. He's holding a ball and describing a geometric horizon on the ball. Where would you see the edge of the ball? That would be a geometric horizon. And then when he talks about going up to the heights that Felix Baumgartner went up to, he's saying you won't see the curve of the Earth at 120,000 feet, meaning you won't see the geometric horizon bend, allowing both parties to simultaneously beg the question that the horizon is a physical geometric Earth curve obstruction, and how much it would be perceived to be bending on one axis when you rise in altitude. It still requires the physicality that he's got by implication when he holds a globe-shaped beach ball. That globe-shaped beach ball is the thing that tells the audience we're talking about the edge of the beach ball and how much you can see and how much it obscures, or in this instance, how much it bends at altitude. Because it's a physical geometric Earth curve edge obstruction that he's holding when he holds a ball. He's saying the Earth is this ball. Therefore, the edge of the horizon is the same as the edge of this ball when it blocks things, or you see it curving. But you won't if you're only a millimetre above it. Well, you will. You've got maths to show us just how much we can measure that. But the Earth curve in the maths that says how much we can measure it simultaneously tells us that the horizon cannot ever be visible as a geometric obstruction. That's a thought experiment.
Yeah, exactly. So he's holding a beach ball, just like if I held the basketball, and you could be a foot away from me, or in his case, the audience member, maybe 30 feet in front of him, sitting in a chair as he's talking. We see the shape of the ball. We could see the curvature on the ball. I could see it in the model in his hand, that globe-shaped beach ball. But he's telling me I could go up and I can't see it. But his math holds him to it. At 1 foot, it's got to be 1.22 miles. So he's contradicting himself at the same time.
Yeah, even on the axis that he's claiming you wouldn't see bend, in the advanced parts of the calculations for the globe geometry, yeah, you should see it bend. Again, at ground level. With the composite image, wow, that's a big super chat. Shout out to Retro Bill. Just a little something to get your work off to a jolly start. Cheers to all on the panel as well. Thank you very much indeed for a $100 super chat, Retro Bill. Really do appreciate it. Yeah, he's wrong. In the advanced part of the calculator, you can calculate how much the horizon should bend. And given, albeit with a composite, so we had to stitch together a piece of videography into still images that you could pan across. They'll scroll by on the screen. If I actually had the screenshots rolling, it's been stuck on an image of the Isle of Man from Sandra. But yeah, eventually on these screenshots, you'll see the composite image that Ranty produced for the Isle of Man discussion. And that composite image, you should be able to calculate how much that axis, the horizon, Earth curve, formerly known geometric horizon, formerly known Earth curve, would bend from the ground. Not talking about huge amounts in the air. Woohoo! Arwen's here. Arwen had 500th show today.
Yes, I did. Hello, Nathan. Hello, guys.
Good to have you, Arwen.
Damn, you're at 500 shows? Huh.
Yeah.
Congrats, brother.
500 early bird shows, because I had a more flat earth talk shows before that, of course.
Yeah, man.
I'll put you on
That's
screen.
awesome. Congrats,
Take a bow.
brother.
Take a bow. Put you on screen. Take a bow.
Take a bow.
500 shows. Woo, woo, woo. Well done. We've decided, while you're away, Arwen, to amalgamate the two housekeeping questions that get asked at the start of the show. And the reason I'll repeat, because it's worth repeating. So, any evidence of a physical geometric Earth curve edge, formerly known as the horizon, in their geometric model, and then followed by any signs of Earth curvature of any description. Well, on Ballbusters, Chocolate was really concise to point out that Earth curve is the geometric horizon. That's the assertion. If you go up in height, you're talking about Earth curve when you talk about how much the horizon bends. When you're at the ground and you talk about things being obscured into the distance at the horizon, they're talking about things being obscured by Earth curve, or boats going over Earth curve. So the geometric horizon is Earth curve. We've debunked it. We no longer have a geometric horizon, but there's no point asking for any signs of Earth curve because the answer to that question is yes in the geometric now debunked model only.
You might want to rephrase that first question though, because the way you asked it is there any signs of all of that in their model? And then I'd say, yeah, in their model, it's all there. But if you say any of that in the real world, like in their model, and then that would not be so easy.
Yeah, that's kind of like what I said. What the first question would be, is there any sign of it? And we'll be, yeah, in the model, sure.
Yeah, exactly.
But when we get to question number 2, is there actual Earth curve? Then it will be no.
Okay, so that's supposed to be like that. I mean,
Well, we used to answer the first question with no, right? Because we used to apply that to the Earth. But the answer is yes, because it is required in the model. It's in the model. There's an X at a place that's supposed to be a physical location, right? So yeah, there is a sign of it in the model or in their maths, right? In the geometry. But when we apply that to Earth, it's not there.
I'd like to address the refraction claim.
Go ahead.
Well, it's a modus ponens, but light bending or light changing angles is refraction. So if the horizon is refracted, we should observe changing dip angles to the horizon. We don't observe that, so the horizon cannot be refracted.
No, we do. The horizon changes its position, doesn't it? The whole point is we have varying dip angles. So if you've got a varying dip angle because of constant refraction, how are you going to derive radius from it? In other words, the Al-Biruni method, you're drawing a triangle basically from your point at the top of the mountain to the horizon. But if that's moving around, you're not measuring a physical geometric location to derive a radius. That's the point. But let me just correct you slightly, just so you rewired better, without sounding rude. If you haven't got a straight line to the horizon, then you can't do geometry. So their argument is to say that the light has reached us and been deviated from straight. Well, geometry requires a straight line between the point that you're measuring, which would be the tangent point, the edge of their curve they claim, and you as the observer inside profile. Well, you're going to draw a straight line between the two. The line is called a tangent. That straight line. Well, every time they argue because they're idiots, well, it's refracted. Oh, right, so not geometric then. Now, they're idiots. The best one was the one that was the most pompous and proud about this fact, AB Science. He went out of his way to declare how we were all idiots, while simultaneously sacrificing his own geometric certitude of a sphere Earth by saying that we don't have any straight lines to it, and then drawing donkey dick geometry for me to use constantly over and over again in the little clips I use. A straight line we haven't got, and a bent donkey dick line to a different position. You know what I mean? In other words, you don't have geometry then. You don't have a straight line between this fake point that moves throughout the day. So if it's refracted, it's not geometric.